In previous videos, I discussed solving and factoring polynomials. This video will discuss finding zeros of polynomials by graphing and factoring. You'll need to be familiar with terms such as multiplicity, which is shown at the bottom. You will also need to know that the words zero, root, solution, and x-intercept are often used interchangeably, but they mean the same thing. And finally, if I am given a polynomial that looks like the one that I'm pointing to right now, you might want to use something called the rational root theorem to determine what factors could possibly make up, well, how to find your zeros for this polynomial. So the rational root theorem finds all your possible rational roots. So the way that you would look for that is you would look for P over Q. P represents your constant. So in this example, 16 is my constant, and then Q represents the leading coefficient. In this instance, the number 1 is the leading coefficient. So if I'm setting it up in fraction form, which is P over Q, it looks like this, 16 over 1. The top numerator consists of all the factors for P, which is 16. So all of these can be plus or minus. So plus or minus 1, plus or minus 2, so on and so forth. And then you would do the exact same for the denominator. So it happens to be a 1 here, which makes your life easier, plus or minus 1, which means these are the only possible real numbers that will be factors for this polynomial. So anyway, it could be positive or negative, one of these numbers. If, for instance, this number at the bottom happened to have been a 3, then you would have to list all the factors of 3, plus or minus 1 and plus or minus 3. In addition, you would also have to consider 4 over 3, 2 over 3, 8 over 3, 16 over 3, 1 over 3 as being a factor of whatever polynomial they had given you, if this was a 3 as a leading coefficient. So pay attention to that, because for me, I'm going to use the calculator, the graphing calculator, and the fraction parts you're not going to be able to find in there, but as far as when you're looking for your zeros, this is a good starting place. All right, so that's the rational root theorem. This is the same example that I was just discussing. And so you may say, well, I don't even know where to start. If you cannot factor by grouping or using the box method, what I would advise is using your graphing calculator. So I've already typed this in to save time, but what you would do is press the Y equals button, and then you would type in your polynomial. Do not try to type in equals 0. That's accounted for here. See the equal sign, and then the 0 is representative of your Y value. And sometimes you'll see f of x. That's what that represents. Once you get this information, now what you need to do is you're going to put, you're going to type the second button, and then you're going to go to table, which is the graph button. What you're looking for is what x value can I use here in my original polynomial to give me a y value of 0. So I'm looking for anything that will give me 0 under y. And I notice here that the number 2 is what can be used to make this true. So I also need to recall that if I am given whatever my highest degree is, that's how many answers that I'm going to have. So the way you want to start this problem out is the calculator just told you that 2 is one of your actual factors. So I would also start, well, I'll do that in a minute. So synthetic division is where I'm going to start, but I needed a divisor, so I just found it in my calculator. So 1, negative 8, 24, negative 32, and 16 are my coefficients and my constants that I'm using. I'm getting that information from the numbers above in this polynomial. That's all I want to bring down. I don't want to bring down the variables just yet. So in synthetic division, I'm going to bring down that first number, which is 1. Everything below the line is going to be multiplied. Everything above will be added. 1 times 2 is 2. Negative 8 plus 2 is negative 6. Negative 6 times 2 is negative 12. 24 minus 12 is positive 12. 12 times 2 is positive 24. Negative 32 plus 24 is negative 8, and then negative 8 times 2 is negative 16. If I am doing this correct, I know for a fact that this will be 0 because we just looked in the graphing calculator and it told me when x is 2, then y is 0. So that's what that means. So now I'm going to rewrite this and continue on. So for this one at the bottom, I go down 1 degree. So my initial degree was x to the 4th. I'm now going to change this to x to the 3rd, x squared, x, and then this is my constant. I want to do the actual synthetic division again. I don't know if I can use that 2 again. I'm going to try it. So otherwise, you would just take this information and now put this in the calculator under y equals in the graphing calculator. But let's try 2 again. And this time we're using these new coefficients. We're using 1, -6, 12, and -8. Again, the first number always goes down, and then I'm multiplying everything that's on the bottom of under the line times the divisor, and then I'm adding everything on top down. 1 times 2 is 2, -6 plus 2 is -4, -4 times 2 is -8, 12 minus 8 is +4, and 4 times 2 is +8. So far, so good. All right, so that means I have another. Again, I have 4 answers that I'm looking for. So far, this is an answer. This is an answer. When I say answer, I mean zeros. So I have a set of 2 and another 2 so far. So let's keep going. So this time I have x squared because we were just at x cubed and we go down a degree each time. X, and then the sign here is a positive. So I could either do another synthetic division, or I could just look at this as x squared minus 4x plus 4 and ask myself if there is any numbers that I can use to put it in factor form. And I can. A times C is going to be 4. And if I'm trying to look for 2 factors that will multiply to give me this 4, but they would add to give me that -4, that would be -2 times -2. That information is going to go inside of the parentheses. So I have x squared, which simply means x times itself. And then I have these 2 factors that I just came up with. However, I am solving, which means it's going to equal 0. That means that I am going to take this information, and let's just start up here, and I'm going to rewrite it as x minus 2 equals 0, x minus 2 equals 0, and I solve for the variable x. So what I do to one side, I do to the other, and that's the inverse. So x is going to be a +2, and the same thing here. Still, I'm sorry, +2, still +2. So x is +2. What I have discovered is I have all 4 answers. So instead of writing it like this, x equals the set of 2, 2, 2, and 2, what we typically will see is 2 with a multiplicity, and it may not even say with a, it just may say multiplicity of 4. So this is actually, in fact, my answer, because I was asked to find the zeros. That's the whole purpose of this video. We're trying to find the zeros, and the zeros are all 2s in this instance. But you would write it as 2 with a multiplicity of 4, because how many times do you see 2? You see it 4 times. 1, 2, 3, 4. That's what multiplicity means. How many times you see that factor. Okay. So here, if I am trying to start and I want to factor by grouping, but I see that I can't because it wouldn't work, then what I would advise, again, is I would go to my calculator. I'm going to go to y equals. If there's something there, just go ahead and clear it out. There's the clear button. And now my x is here, and I want to raise it to the 3rd power. It's still as an exponent, so I have to use my right arrow to bring it down, minus 6x. And I want to raise that to the 2nd power. And again, now let's see, minus 64x minus 45. And again, do not try to type =0. That's already accounted for. Once I have my polynomial in, I would press second, and I want to get to the table, which is in blue. That's the purpose of pressing that second. And I am looking for the zeros in the Y column. Now, if I'm thinking about my rational root theorem, that means that negative 45 divided by 1, I'm looking for all the factors of 45. So that's my starting place. So I'm going to go down, and that includes the negative numbers as well. So hopefully this, okay, yeah. So I see a negative 5, and I have a 0. So for the sake of time, I already know that that's going to be my only 0, but you could go through and look for positive 5, negative 9, 3, so on and so forth, all of the factors of 45. So once I get that information, I said it was negative 5, then I can start my synthetic division using the coefficients above, 1, negative 6, negative 64, negative 45. Bring this 1 down and then start the process of multiplying everything under the line and then adding everything above. So that's negative 5, negative 11 times negative 5, positive 55, negative 64 plus 55, negative 9. Negative 9 times negative 5 is positive 45. And again, I know that this is going to be 0 because the calculator just told me whenever I see a negative 5, my y would be 0. So now I'm going to go back in and I'm going to go down 1 degree. This is now x squared, x, and then this is just a constant. I can look at this and know that there's no way I can factor it because there's not anything that I can multiply to give me 9, but then add to give me negative 11. So I would have to recall the quadratic formula. The quadratic formula states that x is going to equal to negative b plus or minus the square root of b squared minus 4 times ac all over 2a. So let's identify here, because this is what we're working with. We're no longer working with that one. We've already got the answer for the new coefficient. So our A in this case is 1, B is negative 11, and C is negative 9. Pay close attention when your B is negative because the formula also has a negative in it. So don't get confused by that. You still have to account for that. All right, so x is going to equal negative times negative 11, because again, let's just make sure you can still see the formula here. All right, because again, negative, and then b, just go ahead and then put it in parentheses, and that way hopefully it won't confuse you. Square root, and that b is still the same, it's still negative 11, but this time you're squaring it, minus 4 times a, which we said is 1, and then c, which is negative 9, all divided by 2 times that same a, which is 1. So if I'm doing it right, I see that both b's are the same and both a's are the same. And now I just look at my c and verify that. If I'm putting this in the calculator, well, actually, we won't do the calculator. We're going to go ahead and manually do it for those who need to understand how this works. Well, the first thing you want to do is distribute that negative, which will change this to a positive 11 plus or minus, take the square root. When you put this in the calculator, make sure you put it in parentheses so that you will end up with a positive 121 minus, well, actually it's going to be plus because negative times negative is going to turn to a positive, and then 4 times 9 is 36. Pay attention to that also. 2 times 1 is 2. Once I further simplify this, I am going to end up with x is equal to 11 plus or minus, and then under the radical, if I add 121 plus 36, I end up with 157, which I can no longer simplify, all divided by 2. Well, if I recall, I'm looking at my highest exponent from my original problem, and my highest exponent is 3. So that means I am going to have 3 answers. I've already determined that one of those answers is 5, negative 5. Okay, so keep up with that. So in the end, I'm going to have 3 answers, one of which is negative 5, and it does not have a multiplicity. It's only shown one time. And then the other is 11 over 2. I'm just going to separate it, plus square root of 157 over 2, and also 11 over 2 minus square root of 157 over 2. So this is my answer. I have 1, 2, 3 answers. So this is where the irrational root theorem comes into play, because as you can see, I have a, just have it on kind of, okay, I do not have a real number here. So that's possible as well. Sometimes you can't factor and you have to use other means. So sometimes they will give you a graph. So I wanted to just bring to your attention two graphs that you might see that will tell you that you're going to have a multiplicity, where you're going to have multiplicity in it. Okay, so one of them looks like it's bouncing off of the x-axis. Remember, your x-axis is the one that's going left and right, horizontal. So if you ever see a graph bounce off, that means this particular point is going to count 2 times. It's going to have a multiplicity of 2. All right, so here, that is 0, multiplicity of 2. But if I'm looking at this graph, and you'll learn this later, how to determine which exponent or which degree it is. This one is to the 3rd degree. This is not x cubed. However, I'm just giving you an example of the exponent, because this is a whole polynomial. I just didn't write it out. It can have a number in front, so on and so forth. But I know that the highest degree for this particular graph is going to be cubed. So my other point that's on the x-axis is 2. So this is my answer. I have 1, 2, 3 zeros. So that's how this one will work. Another way that you can see that is just highlight your x-axis. And whatever points are touching from your graph, those are your zeros. So again, this one is called bounce because it's bouncing off. And whenever you see a bounce like that, that means it's going to have a multiplicity of 2. The next one that you'll see sometimes is called a snake. And this particular graph, like I said, it's not exactly x to the 4th. However, I'm just letting you know that the highest degree is 4, and you'll learn how to distinguish that later. So what you want to look for in a snake is when the graph is kind of lingering around the x-axis. It's like slithering there. So this particular point then will count as 3. So multiplicity of 3. Where is that point? It's where x is equal to -1. So -1 multiplicity, and I'm just abbreviating, 3. So if I see that it's kind of lingering around, that means it's going to count as 3. And then again, if I go over, I hit another spot, and that's at 2. So I also have a 0 at 2. Again, highlight your x-axis, and where are the points? So you see only 2 points, but if you understand how snake works, that means, oh, well, this particular point counts as 3 points. So if I were writing this out, it's really like -1, -1, -1, and 2. So then I accounted for my 4 zeros. These are all my zeros. Okay, that's how that works. I also just wanted to remind you the difference between factoring and solving, because some people still get that mixed up. So you can just pause and read through this if you need to. And also just know, whenever you have long polynomials with high degrees, if you cannot factor them using the box method or factoring by grouping, you definitely want to use your graphing calculator, that table, to assist you with those factors. And what you're looking for is your y value to be 0, not your x value, your y. So make sure that you understand that. Okay? Thank you guys. Have a great one.